All right, let's go ahead and look at some review problems for our first test. Now, everything's about limits, so obviously remember, the first thing we want to always try with limits is to plug in a value. If you get a real number, then typically that's going to be your limit. If you get something like k divided by 0, then you're typically either going to get positive or negative infinity, or it does not exist. If you get k over infinity, that's typically when you're going to divide the leading terms, but generally that's going to go to 0 if you have a number over infinity. And then if you get 0 over 0, this is where we typically have to factor or do the conjugate or something like that. So just keep that in mind as we're going through these problems. The first thing I'm always going to do is plug the value in. So this first one says the limit as x approaches 1 of 5x minus 4. So just like we said, we'll plug it in, we'll see what we get. So I'm going to get 5 times 1 minus 4. So that's 5 minus 4, so that is 1. That's a real number, so I'm pretty confident that's my limit. Now just remember, you can always graph these functions. I could graph 5x minus 4, see what happens as it gets close to 1 from both sides. Let's look at number 2. This is the limit as x approaches negative 2 of x squared times x minus 1. Same strategy. I'm going to plug in negative 2. So negative 2 squared times negative 2 plus 1. I feel pretty good about this. There's no denominator. So that's going to be 4, and that's going to be negative 1. So when I take their product, I get negative 4. Okay. So first two, pretty straightforward so far, nothing crazy. We just plug them in, we get our limit. This one I think is going to be similar in that fashion, because if I plug in 1, I get 1 plus 1 over 1 plus 2. Well, that's simply 2 over 3. So obviously, if you have a plug-in limit on the test, you definitely want to get that one right. Now this one is the first one where I plug it in. So if I get negative 5 squared plus 3 times negative 5 minus 10 over negative 5 plus 5, well, the bottom gives me 0. So anytime you have a bottom of 0, we know we have problems. And the top we have 25 minus 15 minus 10, so that is 0 as well. So if you remember what we said about 0 over 0, that is generally when you are going to have to factor or take the conjugate or do some trig. Well, there's no square roots and there's no trig, so a pretty good idea that I'm going to have to factor here. So this is going to be the limit as x approaches negative 5, x plus 5, and I'll factor the top. So I'm looking at two numbers that multiply to negative 10 that add to positive 3. So that's going to be x plus 5 and x minus 2. As a clue, if you have that factor in the bottom that's making it 0, you want to be able to cancel that out, which in this case we can. So that limit is going to be the same as the limit as x goes to negative 5 of x minus 2. So now we can plug negative 5 in there. Negative 5 minus 2 is going to be negative 7, so that's our limit. Again, graph it, see what happens as you get close to negative 5. All right, let's look at this one. So again, I'm going to plug in 1, see what I get. So I get 1 squared minus 2 times 1 plus 1. Well, I can tell already that's going to be 0. And on the bottom here, I'm going to do the same thing. 1 cubed is 1. Minus 2 times 1 squared plus 1, that's 0 again. So we'll have to factor. Well, the nice thing is, the top is just two numbers that multiply to 1 that add to negative 2, so x minus 1, x minus 1. And if I look at the bottom, I could take an x out, and if I take an x out, I have x squared minus 2x plus 1, which is the exact same. So x minus 1, x minus 1. So in this case, everything cancels out except for that x, so I'm simply left with the limit as x approaches 1 of 1 over x. So we had two sets of the same binomial factor cancel out. So that's just 1 over 1, so that's just 1. Let's look at 6. Now 6 is an interesting one. It's 3 from the right. I believe that's from the right. It's not very clear. So if I plug in 3, I get 1 over 0. That's a problem. So remember, we said when it's 1 over 0, it's probably going to be something that's either positive or negative infinity. So since it's 3 from the right, I'm going to plug in something slightly bigger than 3, 3.00001. So if I plug that in, 3.00001 minus 3, that's going to give me 1 over a really, really, really small positive number, as small as I want. So I take a real number 1 divided by the smallest number I ever want, that's going to be positive infinity. So this thing is going to have a vertical asymptote at 3. So if you graph it from the right, I can almost envision, if this is 3, I know anytime I have a limit of infinity or negative infinity at thing, it's going to be an asymptote. So you can almost envision the graph is going to look something like this, kind of going up at that part from the right. So again, graphing a nice way to check your work. So this one, again, if I plug in 2, I'm getting 1 over 0 squared. So again, anything over 0, typically it's going to be a positive, a negative infinity, or does not exist. Now this one's actually 2. It's not 2 from the left or the right. So if I'm going to do this one, I pretty much have to do the right hand and the left hand limit to see if they agree, because I cannot do it just at once. So I'll do the left hand and right hand limit and see if they agree. So I'm going to take a number slightly bigger than 2.0001 there, and a number slightly smaller than that there, 1.999, and plug it in here. So this is going to give me 1 over a super, super small positive number squared. Well, that's still 1 over, squaring a positive number is still positive, so that's 1 over a really, really, really small number. So that's going to be positive infinity. Now when I plug in the 1.99999, I'm going to get 1 over a really, really small negative number squared. But when I square the negative, remember, I'm going to get 1 over a really, really small positive number, which is also positive infinity. So since both of these go to the same place, the limit is positive infinity. And so now I can almost envision what's happening at 2. I know from this side the graph is going to infinity, and from this side the graph is going to infinity. So it should look something like that around 2. Eight is going to be another one that kind of deals with the infinity. This is the left-hand side of the one we did in number 6. So it's 3 from the left, so I'll pick a number slightly smaller than 3. So that's going to give me 1 over a really, really, really small negative number. So same thing, 1 over a small negative. It's not squared or anything, so that's negative infinity. So if I go back above from that graph I did earlier, I know from the left it's going to a negative infinity, so it's going to dive down somewhere like this. I don't know what happens in between, but I know at that vertical asymptote, that's kind of how it behaves. And again, Desmos, great graph to check that out. All right, let's look at 9 and 10. They did not appear in my document, so I'm just going to write them in here. So this one is the limit as h goes to 0 of x plus h squared minus 13x plus h minus x squared minus 13x minus 5. So whenever you have the h going to 0 and you have the things with the x's, your answer should have an x in it. So in this case, I'm just going to expand my polynomials. So x plus h is going to be x squared plus 2xh plus h squared, you know, doing the whole foiling thing, minus 13x minus 13h minus 5 minus x squared plus 13x plus 5, because I'm just distributing that negative, all over h. And like we've seen lots of times, lots of good stuff should happen. 13x's go away, 5's go away, and x squareds go away. So I'm simply left with the limit as h goes to 0 of 2xh plus h squared minus 13h. But the good news is these all have an h over h. So I can factor out an h from the top. Limit as h goes to 0. So we have 2x plus h minus 13 over h. And so then these will cancel. So now if I plug the 0 in for h, it's going to go away, but I'm still left with the other two terms. So my answer is 2x minus 13. So always take a look at that when you see those. Okay, let's look at the last one, number 10. And it also not show up on my paper, so I'll write that down as well. So this was the limit as x goes to infinity of 3x cubed minus 4x plus 7 over 2x cubed minus 7x squared plus 4x minus 1. Now the key here is, if you look at a limit at infinity, all you have to really do is look at the terms on the top and bottom with the highest power. So I can look at this limit, and this would just simply become the limit as x goes to infinity of 3x cubed over 2x cubed. Well, these cancel out, and that just leaves me 3 halves, so my limit is 3 halves. The biggest thing to remember there is you can only do this thing where you take the leading term of top and bottom if the limit is going to infinity. If it's a regular limit, you cannot do this. Okay, let's look at number 10, which is our second number 10. So in this case, we have the limit of cosine pi x over 6. We are going to plug in 5 for x just to see what we get. That would give me cosine of 5 pi over 6, which is fine, because cosine has an infinite domain, no problems with cosine. So if I do that, I have to know what cosine of 5 pi over 6 is. Well, here's my unit circle. 5 pi over 6 is over here. And since it's something with a 6, I know it's going to be a radical 3 over 2.5. And since it's not very high, I'm pretty confident the half is there, and radical 3 over 2 is there. But it's negative because in quadrant 2, remember, x is less than 0 and y is greater than 0, because you go left and up. So if you don't know your unit circle, can't memorize that, that's a quick way to know it. If it has a bottom of 4, it's almost always going to be root 2 over 2, root 2 over 2. And if it's one of the 6 or 3s, it's either going to be root 3 over 2 first or second. So in this case, we want the cosine, so this one is just negative radical 3 over 2. Another way is you could obviously graph it and see where it is at 5 pi over 6. And obviously half is a really nice decimal and radical 3 over 2 is not. So you can kind of use that to also figure out your answer. All right, let's go ahead and look at this one. The limit as x goes to pi from the right of x over 2. Well, the bad news is this is coming from the right. If I plug it in, I get undefined, because tangent at pi over 2 is undefined. Because here's pi over 2. And it is 0, 1. But remember, tangent is y over x, so that's 1 over 0. So that's undefined. So if I'm coming from pi from the right, so here's pi over here. Well, if you remember, take calculus. So if I'm coming from the right, so if I'm taking angles that are coming from the right, tangent of those angles are always going to be positive from pi. But in this case, I'm plugging in pi over 2. So pi over 2 is over here, so I'm coming from those, from the right. Now in quadrant 2, is tangent positive or negative? Well, sine is positive, so tangent has to be negative. So this is going to be basically 1 over a really, really small negative number. So this should be negative infinity. You could also graph tangent of x over 2. It looks something like this, I believe. Really, we care about it over here at pi. So what you'd see is you'd see this wave that kind of looks like this. So as you go from the right, it's definitely going to negative infinity, which agrees with our algebra. All right, let's go look at number 12. 12 is dealing with vertical asymptotes. So vertical asymptotes, remember we said, is anywhere where you have a limit that is going to be infinity or negative infinity. But generally that's what's going to make the bottom 0. So if I look at this, maybe I could factor this. So if I factor the bottom and the top, so I'll get x minus 2, x plus 2 on the top. And on the bottom, I'm going to get x minus 9, x plus 2. So those will cancel out. So my predicted vertical asymptote, I would say, is going to be x equal 9, because that's what makes the bottom 0. But to check it, I would just take the limit as x approaches 9. From one side, it doesn't matter, of x minus 2 over x minus 9. So if I plug in a number really, really close to 9, a little bigger, 9.0001, plug it in there and there. So on the top, I get 7.00001. And on the bottom, I get a really, really, really small positive number. So if I take 7 divided by the infinitely small positive number, I'm going to get positive infinity. So as long as I get an infinity, generally that means I have an asymptote there. Okay, let's look at number 13. So 13 says find all the vertical asymptotes of this function. Now the good news is if I look at x squared plus 25, there's nothing that's going to make that 0. Because if I square a number and get 0, or I square a number, I get a positive number, add 25, I'll never get 0. So this is not equal to 0. But I have a log. And remember, anything you plug in that makes the log 0 would also be an asymptote. So I also have to look at x squared minus 64 and see where that equals 0. And this actually has 2 zeros. Because I could factor this and make it x minus 8, x plus 8 equals 0. So x is going to equal plus or minus 8. So those are going to be my 2 vertical asymptotes, plus or minus 8. Again, I'd really encourage you, especially on the asymptote problems, graph it. It's a really nice way to check if you have it correct. All right, for 14 and 15, we're doing some of our limits that are 0 over 0. I promise you, if you plug them in, you get 0 over 0. So these are some of our conjugate limits. So what I would do is, remember, for the conjugate, we're going to multiply by the conjugate of the numerator. So x plus 10 plus 4, and radical x plus 10 plus 4. So if I FOIL the top, I'm going to get x plus 10, and then I'm going to get minus 16. Remember, the inner and outer terms will cancel out. This is still the limit as x goes to 6. And the bottom, I'm going to get x minus 6. And then remember, don't touch the other part. Kind of leave it the same. So it looks like that. And so now this will give me the limit as x goes to 6. Now the top, quite nicely, becomes x minus 6 over x minus 6, radical x plus 10 plus 4. Well, those cancel out now. So now I can plug the 6 in here, and I get 1 over the square root of 16 plus 4. Well, but hey, the square root of 16 is 4, so this is 1 over 8. All right, let's look at this one, which is one of our ones with the h and the x and all that kind of good stuff. So same process, only the goal is we should end up with something with x. So I'll multiply by the conjugate. So that's radical x plus h plus 2 plus radical x plus 2 all over h times radical x plus, well, I already have the h. X plus h plus 2 plus radical x plus 2. So when I FOIL this, this just becomes x plus h plus 2. And this is going to become minus x plus 2, because remember that minus carries through, over h radical x plus h plus 2 plus radical x plus 2. So the good news is you have a lot of things that cancel, because this is minus x, this minus x will cancel with this, and this is 2 and negative 2 because I distribute through. So now I just have the limit as h goes to 0 of h over h radical x plus h plus 2 plus radical x plus 2. Well, look, the h's cancel. So now if I put 0 in for h, I'll just end up with 1 over radical x plus 2 plus radical x plus 2, which is going to be 1 over 2 radical x plus 2. Suckers. All right, the last problems are probably the easiest when you're given the graph. Can we find some of our limits? But just like we always have, you can just use the graph to see where it approaches. So the first one says, what happens if I'm approaching 2 from the right? Well, here's 2, so as I approach to the right, it appears that's just going to 2, but I think this says negative 2. Yeah, it says negative 2. So if you're going from negative 2 from the right, you're going to this value, and that is just simply 2. Now, if you're coming from the left is going this direction on this line segment, so that is going to be going to negative 2, and so the limit at negative 2 does not exist because they're going different places. And we always said if they're going different places, the limit does not exist. All right, 19 says the limit as we come from negative 5 from the left. So there's negative 5. I'm coming from the left side. Pretty clearly, we're going from negative infinity. So, as we look at the function as it goes to positive infinity, what's happening as the x's get bigger and bigger and bigger and bigger? Well, this just seems to go getting smaller and smaller and smaller and smaller, so this is ending up at negative infinity as well. All right, last one we have is it's going to 0. What happens as we go to 0? Well, 0 is just a number, so from this side it looks like I'm going to 4. From this side I'm going to 4. So as long as I'm going to the same spot, that's my limit. So my limit is 4. So a lot of questions, a lot of different things. Hopefully these are pretty okay. Bring questions to the class. We'll certainly go over them in preparation for your test.